Hello everyone, and welcome back to the channel. The Tian Shan Shengli Tunnel in Xinjiang, China. This is not just another road tunnel. This is a 22-kilometer mountain tunnel carved straight through the heart of the Tian Shan Mountains. One of the longest and most challenging expressway tunnels ever built. And what makes it even more incredible is not just its length, but the brutal place where it was built. Freezing high-altitude valleys, unstable mountain rock, deep fault zones, powerful groundwater.
Check the pressure on Rig 3. It's holding steady, but watch the ice build up.
Because we bring you the most unbelievable mega-project construction stories from around the world. Now, imagine standing in front of a massive mountain wall in the middle of Xinjiang. Behind that wall is more than 22,000 meters of rock.
And the mission is almost impossible. Build a modern expressway straight through it.
So vehicles can cross the Tian Shan range in minutes, instead of struggling for hours over dangerous mountain roads.
But the engineers could not simply dig one tunnel and hope it worked. They designed a complex underground system.
The snatches. 2 large highway tunnels for traffic, 1 smaller center service tunnel between them.
It was a hidden underground machine. The first step was not excavation. It was understanding the mountain. Survey teams moved across the frozen valley with drones, GPS equipment, with drilling rigs, and geological sensors. They mapped the route, tested the rock, studied the water pressure, and identified dangerous fault zones deep inside the mountain. Every crack mattered. Every weak layer mattered. Because one wrong decision underground could mean collapse, flooding, or a trapped machine.
Easy now, swing it to the left. We need that section secured before the next lift.
Temporary roads were cut into steep slopes. Work platforms were leveled.
Power stations, ventilation systems, concrete plants, worker camps, equipment yards,
and spoil disposal zones were set up in the cold alpine environment. Only after that could the real battle begin. At the North Portal, machines carved the first cut into the mountain slope. Excavators shaped the entrance area into stepped benches.
Workers removed loose rock, drilled rock bolts into the slope, covered it with steel mesh,
and sprayed shotcrete to lock the unstable surface in place. A reinforced retaining wall was built at the base, followed by a heavy concrete portal frame. This portal was not decoration. It was a shield, protecting the tunnel entrance from the mountain above. Then the first main tunnel bore opened. Drill jumbos entered the shallow, dark opening and began drilling precise blast hole patterns into the rock face. After each controlled blast, the tunnel filled with dust and broken rock. Ventilation fans cleared the air. Loaders removed the debris. Crews inspected the roof and walls. Then came the support system: rock bolts, steel mesh, steel ribs, and shotcrete. This cycle repeated again and again. Drill, blast, ventilate, muck out, support. Every few meters had to be won from the mountain. Next, the second main bore began beside it. Now the construction zone started to reveal the true shape of the project.
2 large highway tunnels, side by side, both slowly advancing into the Tian Shan rock.
But the most fascinating part was the center service tunnel. Between the two highway bores, engineers prepared a TBM launch chamber, a reinforced underground space where a giant tunnel boring machine could be assembled. Piece by piece, the TBM arrived at the portal. Cutter head segments, shield body sections, hydraulic systems, backup gantries, cables, conveyors, and service equipment.
The cutter head was lifted into place like the face of a giant mechanical beast.
Once assembled, the TBM began cutting the center service tunnel. Its rotating head ground into the hard mountain rock. Broken rock chips moved along conveyor belts. Behind the machine, workers installed precast invert blocks to create a stable floor for equipment and logistics. This center tunnel became the construction spine of the entire project. Piece by piece, the TBM arrived at the portal. Cutter head segments, shield body sections, hydraulic systems. These passages were critical for emergency access, maintenance, logistics, and future safety. Each one had to be drilled, excavated, supported, reinforced, and connected carefully to the larger tunnels. But the mountain still had more challenges waiting. Inside the Tian Shan range, workers faced fractured rock, water-bearing zones, soft rock deformation, and high ground pressure. When probes detected weak rock ahead, crews paused excavation and injected grout into the mountain to stabilize it. When water appeared, drainage systems and pumps were installed. When rock pressure increased, support was strengthened.
Nothing moved forward until the mountain was made safe. Then came the ventilation shafts.
High above the tunnel, on freezing mountain slopes, crews built circular shaft collars and began sinking deep vertical shafts down toward the tunnel system.
Rock was broken at the bottom, lifted out by skip buckets, and the walls were supported with shotcrete and concrete lining. These shafts later connected to underground fan chambers, forming the lungs of the tunnel.
For a tunnel this long, ventilation is not optional. It is survival. Once the excavation and support systems were complete, the tunnel began to transform from a raw construction space into a real expressway.
Drainage galleries and side ditches were built to control groundwater. Waterproof membranes were installed over the shotcrete. Rebar cages were tied along the arch. Giant formwork trolleys moved through the tunnel, pouring the smooth secondary concrete lining. Then came the floor. Invert slabs, cable trenches, drainage channels, road base, and pavement. The dark construction tunnel slowly became a clean, modern highway corridor. Finally, crews installed the systems that make a long tunnel safe.
Lighting, ventilation fans, fire hydrants, emergency cabinets, CCTV cameras, air quality sensors,
Communication cables, smoke extraction equipment, traffic control systems, and an operations center watching everything in real time.
But even then, the tunnel was not ready for the public. It had to be tested.
Ventilation fans were pushed to full power. Smoke extraction simulations were performed.
Fire hydrants were pressure tested. Emergency passages were inspected. Cameras and sensors were calibrated. Inspection vehicles drove slowly through the tunnel. Then high-speed test runs confirmed that the road surface, lighting, airflow, and control systems all worked together. Cameras and sensors were calibrated. Inspection vehicles drove slowly through the tunnel.
And fighting the mountain, public vehicles entered the tunnel for the first time.
What once required a long and dangerous mountain crossing could now be completed. Through a controlled, illuminated expressway deep inside the Tian Shan range. This is why the Tian Shan Shengli Tunnel is more than a tunnel. It is a story of engineering patience, a story of logistics in extreme terrain, a story of thousands of workers building piece by piece through one of the harshest mountain environments in China. From frozen survey stakes on a barren slope, to the first blast in the rock, to the giant TBM cutting the center tunnel, to the deep ventilation shafts, to the final glow of traffic lights inside the completed bore, every step had to happen in the right order, because in mega project construction, the mountain does not forgive shortcuts.
And that is how China built one of the most astonishing mountain expressway tunnels in the world.
If you enjoyed this construction journey, don't forget to like the video, subscribe to the channel,
and turn on the notification bell. In the next video, we'll uncover another impossible mega project, and reveal how engineers turned it from a dream into reality. Thanks for watching, and I'll see you in the next one.